Hello and welcome. In this lab, we will use Docker to containerize a REST API application. Let's get started. The application we are going to work with is called the Fibonacci sample application. You can find a link to its GitHub repository in the resources attached to this lab. This application has two layers: a backend which implements the Fibonacci function as a REST API, and a front end that invokes the REST API and prints the results. In this part, we will focus on the backend layer. Let's take a look at the Fibonacci sample GitHub repository. We have the Fibonacci backend and the Fibonacci front end. Click on the Fibonacci backend and you can see the api.py Python file that implements the REST API for the Fibonacci function. And this is the definition of the Fibonacci function, which implements the well-known Fibonacci sequence. You can find a PDF file with the full list of the commands you will run under the resources attached to this lab. Please download this PDF now and keep it handy to help you with typing the commands for this lab. Let's clone the source code for the Fibonacci application. Copy this repository identifier and then in your terminal type git clone and paste the repository identifier, and this pulls the code into our machine. If you are on a Windows machine and your terminal is the Windows subsystem for Linux terminal, you can type explorer.exe and press enter, and this will launch the file explorer of Windows at your home directory, and then you can navigate to the folder that has the source code for the Fibonacci sample application. Let's take a look at the Dockerfile for the REST API server in the Fibonacci backend. Each line in the Dockerfile is an instruction to add a feature to the Docker image. In Docker terminology, each line adds a layer to the image. This is how we build a software stack into a Docker container, one layer at a time. Note that the Dockerfile builds the software stack from the bottom up. Please note that at line 6 we installed the curl utility because it does not come as part of the Ubuntu image. We will need the curl utility in our testing when we run the container. Also, note that line 12 is commented out. If enabled, this line passes optional arguments to the application, instructing it to display a version number of 3.0 and to enable writing log messages. Please do not enable this line just yet. We will get to it later in another lab. To proceed with the rest of this lab, you will need to create a Docker account. Open your browser and follow this link to create a Docker account if you did not have one already. You can find the link to create a Docker account in the resources attached to this lab. Save the username and password for your Docker account as you will need them later in this lab. Please pause this video, create your Docker account, then resume this video. Go back to your terminal. Make sure you are in the directory for the Fibonacci backend application and run this command to build the Docker image for the backend application. Building the Docker image will take a few minutes, so please be patient. I am speeding up the video here. Notice the output on the console while the Docker builds your container image layer by layer. There are 8 layers in this Dockerfile, one for each Docker instruction. For instance, layer 1 of 8 comes from the instruction from Ubuntu at line 1. It copies contents of an Ubuntu image to your container image. Now that the container image is built, we are ready to run a container based on it. So, type this command in your terminal. Notice the -d option, which runs the container in detached mode, which means it runs in the background so that it does not block your terminal on the host machine. The container was run successfully in the background, and the ID of the container is printed on the terminal. List available containers. This is the Fibonacci backend container. Let's copy its ID. The container is running and the REST API is available. The server is not exposed though, so we need to log into the server and test the REST API using the curl utility. Run the following command to access the shell of the container. Note that the prompt shows the ID value of the container and that you are logged in using root, which is the default user in a container. Furthermore, please note that the host name has the same value as the container ID. You can verify this using the hostname command. Now, test the REST API using the curl utility. Let's try to get the Fibonacci value for 8, which should come as 21. And here is the result. Fibonacci of 8 is 21. Type exit to return to the shell of the host machine. We want to be able to reach the REST API from within the host machine. Start a container and map its port to a host port using this command. Now you can open a web browser on the host machine and execute the REST API. Let's figure the Fibonacci value of 20. Open this link in a browser on your Docker host. Try different values of Fibonacci by changing the number in the URL. We want to store the container image in DockerHub to make it accessible from everywhere. Try to run the following command from your terminal to push the image to DockerHub. If you get this denied error, this means you need to log into DockerHub first using this command. Repeat the command to push the image again. It will pass this time. Check your account on DockerHub and you should see your image there under a new repository. Take a moment to browse your repository page on DockerHub. Note that you can add a README Markdown file to the repository, just as you can do for a GitHub repository. That's it for this lab. You have containerized a REST API application, ran the application and exposed it on a port on the host, tested the application in a web browser, created a Docker account, and pushed your image to DockerHub. You can find a full list of the commands you ran under the resources attached to this lab. Thank you and see you in the next lab.